This lesson will deal with accuracy and precision. Accuracy is on a measuring device measures how close the measured value is to its true value. For example, if you use a 1 cup measure to measure sugar, how close can you actually be to 1 cup of sugar? Can other people repeat the measurement with the same or different measuring cups, for example, other 1 cup measures, and get the same result? Accuracy depends on how careful you use the device as well. Precision of a measurement is restricted by the limitations of the measurement scale. If the smallest division of your ruler is millimeters, then you can only make a measurement to the nearest millimeter. Because the precision of a measurement depends on the limitations of the measuring device, there is some uncertainty in that measurement. That means that you might think you're close to 11 millimeters, but you could be a little bit bigger than 11 millimeters or a little bit smaller. Precision of this ruler is 1 millimeter. The uncertainty is always half the measure of precision. So the precision is the smallest units that are in the whatever measuring device you're using. In this case, you are using a centimeter, but it's broken down into millimeters. So your precision is 1 millimeter, and then the uncertainty is half of that. The plus or minus means that you could be bigger than 11 millimeters by half a millimeter, or you could be smaller by half a millimeter. So you could be half a millimeter out one way or the other. A gardener mixes fertilizers with 1 liter of water. The water jug has lines showing the volume every 0.1 of a liter. The uncertainty is half of that smallest measurement, so 0.05 of a liter. The amount of water in the jug can be as much as plus 0.5, so it could be up to 1.05 liters, or it could be less by 0.5, so it could be 0.95 liters. We write it as the unit of measure, 1 liter, plus or minus the uncertainty. If you add another volume, so you had 2 containers of fertilizer, what happens to the resulting volume? Well, now we have 2 liters of fertilizer, but the uncertainty also has to be added together. So when you measured the first time, you could have been out 0.05 of a liter. When you measured the second time, you also could be out 0.05 of a liter. So together, the combined volume would also combine the uncertainty. So you would add the 2 certainties together. Okay, so let's take a look at example 1. A baker sets an oven timer that displays 1-minute increments to 45 minutes. Well, then the precision is 1 minute. The uncertainty is going to be half of that. So we write plus or minus because it could be out half a minute either way. So 0.5 of a minute. A nurse measures a patient's temperature to be 36.8. Because you are in tenths on the degrees, the precision is 0.1 degree. The uncertainty is half of that, so plus or minus 0.05 degrees Celsius. A jeweler weighs gold at 1.243 grams. So you're down to the thousands. So the precision is 0.001, so 1/1000th of a gram. The uncertainty is half of that, plus or minus 0.0005 of a gram. And the last one, a survey technician records the distance between 2 survey points as 1,200 meters. Now, this actually is kind of unclear because we don't know if you are measuring in meters, or if we're measuring in 10 meters, or if you're measuring in 100 meters, because the last 2 digits are zeros. So we're not sure if that's accurate or precise, or if you are just rounding them off. So if the precision was to 100 meters, then the uncertainty is plus or minus 50 meters. So you need a little more information for this question to know how precise the measurement is. Because of the 2 zeros, you're not sure if that is the type of measuring tool you used or just rounding. Okay, we're going to look at a situation where we need to think about what level of precision is needed. George is a finishing carpenter in Fort Simpson, Northwest Territories. He's installing a run of crown molding around the top of a kitchen cupboard. He has 3 tape measures, each marked in a different scale. The first tape is measured in centimeters. The second one is marked in half a centimeter. The third one is marked in millimeters. Okay? He uses each tape to measure a piece of molding. Using tape 1, George could say that the piece is 12 centimeters long. The tape does not allow him to state a more precise measurement without estimating. Thus, the length is greater than or equal to 11.5 centimeters or less than 11 or 12.5. That could be written as 12 centimeters plus or minus 0.5. Okay, so if we used tape number 2 is measured in half a centimeter. So he could write that it was 12.5 centimeters, and now, so the precision is half a centimeter, and the uncertainty is 0.025. Need to make a correction. Half of 0.5 is 0.25. Okay, so this would be 12.5 plus or minus 0.25 centimeters. If you use tape 3, which is in millimeters, we could say something like it was 12.3 centimeters plus or minus. So the precision is 0.1 of a centimeter, which is 0.05 of a centimeter. We could then say that the uncertainty is 0.5 centimeters. Which tape measure is more precise? Well, measurement number 3. Measuring tape number 3. And why? Because it is in the smallest increments. So if you use a measuring device that has the smallest divisions in it, so in this case millimeters, it's going to be more precise than one that's broken down into centimeters or broken into meters. Is it important that the joint between the crown molding and the cabinets is not visible? So you don't really want to see a space there. Which level of precision should George choose? So I would use tape number 3 because it's going to be most precise. You're going to get the nicest, closest finish if you measure them with the most precise measurement. If you were building a fence, which of the 3 measuring tapes would be best choice for measuring the height of the fence? You could use any one of them, but you could use tape number 3 or number 1. You don't need the precision of 1 millimeter for a fence post. So in this case, if you're out by a half a centimeter one way or the other, it would not make a big difference to the fence and how your fence looked when it was done. In winter sports, such as alpine skiing, snowboarding, speed skating, they have to be very precise in the use of the timer for first, second, third place. The difference at the Paralympic Games in Whistler between the first and the second place winner was only 0.366 of a second. So how precise was the timer? The timer was 0.01 of a second, which means the uncertainty is half of that. Write the first place finisher's time, including the measurement uncertainty. So you would take the time, 1 minute, 27 seconds, and 51 100ths of a second, plus or minus 0.005 seconds. What was the time of the second place finisher, including the measurements of uncertainty? So we would have to take her time, and add 0.66 because she was that far behind. So her finishing time was 1 minute, 28 seconds, and 17 100ths of a second. But we also have to add two uncertainties together because there's the uncertainty for the first place racer and the uncertainty in the measure of the second place racer. So we would have to take two uncertainties and add them together. That means that her time would be written as 1 minute, 28 seconds, and 17 100ths of a second, plus or minus 0.01 second. Now, if we took and added 0.01 second, we would get 1.2818, or if you subtracted it, would be 1.2816. Okay? So her time could be anywhere from the first time to the second time. So the difference of 0.16 to 0.18. Okay, carry out the calculations each person is performing. State the answer in the correct level of precision and calculate the uncertainty. So, kitchen installer is laying out a kitchen design. She plans to install the fridge and stove side by side. She measures the fridge to be 71 plus or minus 0.5 centimeters wide and the stove to be 76 plus or minus 0.5 centimeters. So you would take and add the two together. And you can line them up just like you would add columns of numbers. Okay, so you're going to add them both together. So 71 plus 76 is 147, and the uncertainty added together is 1 centimeter. Okay, so the width of the fridge and stove together could be 146 to 148 centimeters, as they could be out a little bit on their measurements. A shipping clerk calculates the total shipping weight of 3 packages with individual weights of 16.5 kilograms, 2.8 kilograms, and 1.4 kilograms. Okay, so the first thing we should figure out is what the uncertainty is. So the precision is the smallest unit, which is 0.1 kilograms. The uncertainty then is half of that, 0.05 kilograms. So each one of these weights could be plus or minus 0.05 kilograms. So we have 3 of those, 28 plus or minus 0.05 kilograms, 1.4 plus or minus 0.05 kilograms. Okay? Add up the 3 weights, 16, 2.8, 1.4 is 20.7 kilograms, plus or minus 0.15 kilograms. A pipe fitter calculates the length of a 2.505 meter pipe after he has cut a 6 centimeter piece from the end. Now, this one is a little challenging because you are going to you're going to subtract the lengths because you're taking something off, but you will still add the uncertainty because this is plus or minus, okay, your precision is 0.01 meters. Uncertainty is 0.005 meters. Okay, so your uncertainty will still be added together because they're both still uncertain. The measurements could be up or lower than that measurement, so you're going to combine them, but you're actually going to subtract the PC cutoff, which is 6 centimeters. 6 centimeters is 0.06 of a meter. Be very careful that you're working in the same units. This one's in meters, this one's in centimeters. They both have to be the same units. So you're going to subtract 0.06, but you're still going to add the uncertainties, because that's how much they could be out. So you're not going to have 0 uncertainty. You're actually going to be uncertain. 0.01 meters could be out either way, because you could have measured either one of them a little bit off. And the actual pipe now is 1.99 meters. So you could have measured the 2.05 meter pipe a little bit off, or you could have measured the 6 centimeter pipe a little bit off. So that's why we have to combine the uncertainties. This one is added together, but because you cut the piece off, you are subtracting the length. All right, you're going to practice these skills in your workbook, Build Your Skills, page 84 to 89.